Question 19. How much money will I need to have at a retirement? So I can withdraw, keyword, I can withdraw 60,000 a year for 20 years from an account earning 8% compounded annually. Because we want to withdraw money and we want to find out how much money, a big lump sum to have. So we know this is a payout annuity. We use a payout annuity formula. Remember, formula start with amount of money to start with, to withdraw from, equals to withdraw amount. We still use lowercase d to represent, then multiply by a fraction. Okay. And this fraction, the denominator, we have r divided by k. And the numerator, we have, before we have something minus 1. Now we have 1 minus 1 plus r divided by k. Then raised by negative n times k. Well, let's identify our variables. Okay. So P naught, we do not know. We're trying to find. I want you to red color. We try to find a P naught. So, a big lump sum money sitting there for me to withdraw from. And D is a withdrawal amount. So in this case, so D is 60,000 per year. So that gives us two variables. Okay, so D equals to 60,000. And the K, so how many times I do withdraw in a year? K equals 1. And R equals 8%, which is 0.08. And the N is for the next 20 years. So I have identified that D, R, K, and N. So now I can put this data into corresponding variables. So I have D equals to 60,000. So I'm writing 60,000 in the place of D, parentheses, 1 minus 1 plus R is 0.08 divided by K, K is 1, then raised by negative N times K. N is 20 and K is 1. That's the numerator. Denominator, we have R divided by K, which is 0.08 divided by 1. Now the rest is to do the calculations. So leave 60,000 on the side. If we cannot put every data into the calculator in one shot, so we do step by step. Okay. We still have this fraction inside parentheses. The denominator is 0.08 divided by 1. Anything divided by 1 says it's itself. That's 0.08. Then I have 1 minus. Now inside here, I have 0.08 divided by 1, which is 0.08 plus 1, so I get a 1.08. That reads by negative 20, because 20 times 1 is 20. So now I have to use calculator to calculate 1.08 raised by negative 20. So I need to calculate this part first. Then I subtract this number from 1. Then I divide it by 0.08. Then I multiply by 60,000. So let's go to decimals. Let's go. I have to stop share, then share the decimals. Oh, I need to bring decimals up to the screen to do that. Decimals is here. Stop this one. Share decimals. Yeah. So 1.088 raised by negative 20. Negative 20. Then divide, so subtract 1 from this, so 1 minus this number. then divided by, so let's multiply 60,000, then divided by 0.08. Okay, so that give us 60,000. Let's see, something's wrong. So 1.08 raised by -20, subtract from 1, divided by 0.08. Oh, okay, surely. Because I want to withdraw money, right? I want to withdraw $60,000 per year. So for next 20 years, with the interest rate 8%, compounded annually. So I need to do that. I need to have this much money to round it up to 84 cents. I need to have 589. Oh, let me take a picture so I can copy down into the other screen. So $589,088.84 to start with. If we do step by step, like we cannot do this one. So just calculate the inside first to get 0.785, 0.78545. Let's subtract 1 from there. Then divide by 0.08. Then multiply by 60,000. All right. So now let's go back to the other screen. Good notes. Okay. So let's write down the amount of money to start before we withdraw anything. So we need to have in the account 589,088.84, or maybe 85 cents. Right. So let's go back to the question to make sense of all this. The question is asking how much money we need to have in a retirement account to enable us to withdraw $60,000 per year for next 20 years, provided the account offers 8% of interest rate. So we know, because we're withdrawing money from retirement accounts, we know to use a payout annuity formula. So which is this. So we have lumps of money sitting in a retirement account for us to withdraw. So this little d represents the withdrawal amount. And then we have this R, interest rate, K, how many times we do withdraw, or we withdraw per year, for how many years, for next 20 years. So we just put those corresponding values into the corresponding variables, then just do the calculation. Right? If our calculator doesn't allow us to put every data in one shot, and we can do step by step, right? We calculate this exponent, then we subtract from 1, then we divide by 0.08, then in the end we multiply by 60,000. So to get able for us to be able to withdraw $60,000 per year for the next 20 years, so we need to have $589,088.85 in the retirement account. All right, that's question 19.